meaning that it's a range. You all know what it's called range, right? From one point to one point. Basically, when we talk about range, we use a bracket form. See, this one is we call it lower boundary. This is called upper boundary. Chapter 1, right? Remember chapter 1 or chapter 2? We have the frequency distribution table. Remember your quiz also got a lot, right? From lower boundary to lower class limit, upper class limit, remember? It's the same now. So the left hand side will be your lower boundary, the right hand side will be your upper boundary. Okay, so basically when we talk about estimation, we want to estimate this, we call it range. We call this confidence interval. Confidence interval. Short form we call it CI. CI. Now where is this word? This is the word. Everyone can see the highlight one. Okay, so I try to pick the important words. After that I elaborate. Now, it's a technique of estimating unknown population parameters. You all still remember chapter 1, you know, population example? Okay, so let's say we do a survey. We talk about a big group. Parameters equal to what? Equal to variables. Variables like mean of length, mean of the weight. Okay, all these are variables. So we talk about this a lot in the chapter 4. Right? Based on the value, sample statistics. So basically, we use sample to what? Predict for the, or we call it estimate for the population confidence interval. Right? Now, the estimation procedure involves the following steps. Select sample, small group. After that, collect the required information from the members of the sample. Then calculate the value. And then the last one, assign the value. Okay, now these are the steps that actually, if the person involved in survey, then we follow these 4 steps. So for you all, actually just for knowledge only, because we don't do this actual real survey. So don't worry, this one will be tested on. Alright, those of them doing survey research come, they have to follow these steps. Okay, now your job, all of you, is to calculate this confidence interval. Okay, there's a formula there. Estimate the value assigned to the population parameter based on the sample, which is stated already here. Number 2. Now, to estimate the confidence interval, we need one thing, which is called estimator. Here means sample statistics used to estimate the population parameter. So in this case, we have 2 estimator. One of them is using mean, and one they're using variance. Now, I'm sure you all still remember this symbol, right? I always mention, you must know the face, you must know the name. What is this? Mean, right? Chapter 4. This is sample or population? Population. Okay? Sample mean is the bar one. That's why I say you must remember the name, you must remember the face. You don't remember face only. You forget the name. This is sample mean, this is population mean. You cannot tell me both also mean, but it's different. This is for small group. This is for big group. Now, today you're going to learn one more thing. You see this one symbol here? We call this hat. You see like the hat, H-A-T, no hat up, topi. So this symbol represents what? Estimator. The statistics sample that you're going to use to estimate, to calculate the CI. Okay, and remember this one? This is your population variance, right? Remember, this is a sigma. How about sample variance? The S, remember? Chapter 2. Remember sample variance, S squared. So you see the difference between Sample and population, different symbol. Formula also different, right? Chapter 2. Quiz scholar. I remember. There is, right? Find mean, find standard deviation. I think so. Okay. So you see, for estimator, we also put a head there. You see that? But after I see the answer, many people they don't write the head. They don't care and just write everything like mu square and the sigma square because they forgot totally about the head. They thought it's nothing. Actually, very important. In statistics, the symbol is very, very important. Okay? So these are the point estimate, we call it. Two types of estimation. One is using point estimate, using this mean. The other one is using population. So let me introduce to you two types. One is using mean. Example, or we call it X bar. This is sample mean. This population mean. Let's say 77. And then the sigma square or the S square sample variance is 6. Example. Okay. Now, as I mentioned just now, we are going to calculate or we call it estimate the interval, the range. Interval is the range from lower to upper range. Okay. So, given by the two numbers between which the parameter may be considered to lie on. You see, lie on means between the lower to the upper. And interval is constructed with given confidence level. Example, you see, the mean between 66 and 88. So this is lower. This is upper. Remember, right hand side always higher than left hand side. But I see some people in the exam they panic, too panic. They write the smaller on right hand side, bigger value left hand side. So should I minus mark? Yes, I minus mark. The value is correct, but they too panic. Quite wrongly. So the confidence level, this one very important, right? Associated with the confidence interval states how much confidence we have that this interval contains a true population parameter. So actually, how do we define confidence level? Confidence level is actually confidence interval. So if the question asks, what is confidence level? What's the meaning level? Level means how much confidence we have. Level means how much you have confidence that your confidence interval contains the true population parameter. And this confidence level is represented by this. Can you take the highlighter? Highlight this. So I'm going to explain to you what's the meaning alpha. Can you see this symbol? Anyone have seen this symbol before? How do you call this? Alpha. It's a big symbol. Alpha, mu, beta, including the delta or delta virus, omicron, all this for what? Big symbol, right? Do you know that? Right? You study the symbol of COVID. Actually, the WHO name all this based on mathematical symbol. Okay. Now, can I explain to you why we have this confidence level? Consider population with a non-parameter theta. This is theta. Anyone know this? Very common, right? Theta. Also visible. We can find an interval AB. So remember the bracket one, lower, upper, such that the probability, remember chapter 4 normal distribution. Probability, this theta is our what? Just score between A and B, right? Let's say this is your what? Probability, right? Given, so you use table 2, isn't it? Remember table 2? You're given the probability, you find that the score. So I write here table 2. I hope everyone knows what table 2 is. Okay, so we can say that AB means the left and right. Lower upper rate is 95%. Now when you see here is the percentage, which means this is 95%. confidence. If I have this 0.9, means what? 90%. If I have this 0.80 means 80%. If I have this 0.3 means 30%. If I have 0.01, how many percent? 1%. Very, very small. Okay? So why is this percent very important? Because of this one. So this is in percent, right? With the percent given, can you find the alpha? Can you really, right? Okay, I'll show you later. Now, in this case, let's say beta is the z-score, okay? 0.95 is the probability, remember? Percentage of probability that the interval includes the theta. Which means if I draw this, do you still remember normal curve? Everyone? Okay, this is your mean, right? I'm talking about standard. Mean is what? 0, right? Okay, let's say I have the, let's say example. You see that z-score last week, right? It can be positive, can be negative. Do you remember? Z-score can be positive, negative. Sometimes A and B can be both right hand side positive. Sometimes A and B can be both negative. Sometimes A can be negative, B can be positive. As long as the B is more than A, right hand side more than left hand side. So let's say example, I talk about both also positive. A here, B is here. Let's say so your theta must be what? Between here. The theta must be between A and B, lower and upper boundary. So if your theta is between here, and how many percent we are very sure that this theta fall between A and B, given by this probability. So in other words, if I write a report, I want to interpret my confidence level. If I know this percentage, let's say I use 0.95, how do I say? I am 95% sure, or confidence, how we use the word, that this theta, your z-score, is between the lower and upper boundary. So in this part, your job is no longer find the theta. Chapter 4, part 2, right? Use table Z, table 2 to find the z-score, right? So now you're going to find the A and B. Okay, no longer find the z-score. Now we want to find the A and B using the percentage given. Yeah. So how to find the A and B? This is the formula. CI for population mean. Okay, let me talk about population mean first type. There are actually two types. One for population, one for proportion. Okay, population mean we use what? Mean, remember this one? Population mean. Don't confuse with the symbol. As you can see, more and more different symbol comes in, right? Chapter 2, 3, 4, 5. It's all you don't remember the name, at least you remember the face. Okay. If you both also you don't remember, you'll be very confused. Now, the 100 times 1 minus alpha percent confidence interval related to the mean and the variance of another population variance is given by this. So I can say that the CI short form is given by this formula. X bar. Remember X bar? Sample mean. Now remember the question, the note says we use sample mean to estimate. Use sample mean to estimate population parameter. Okay, meaning that, okay, I'll give you an example. Let's say TAR UC got 20,000 students. big group, right? Are you going to do survey based on 20,000? You know what's called survey, right? Impossible. By the time you finish survey 20,000 students, 1 year already. You don't have budget, you don't have manpower. So let's say you take 5%. 5% how many? 1,000, I think. Yeah, check. 5% is it 1,000? 1,000. This is your sample. Remember we learned chapter 1. So we use this sample of calculate the what? X bar, sample mean. And then use this sample mean to estimate the population parameter. That's that. Because 1,000 compared to 20,000, which one easier to do survey? Of course, 1,000 are smaller group, difference by 19,000. You know how much the cost different? You want to do survey, you need cost, right? Yeah. So that's why we use the sample mean to calculate the population confidence interval. So now we don't use the mu. Okay, then plus minus z alpha over 2. Remember the z score? Chapter 4. Okay, alpha over 2. This is the alpha, you can get it from here. I'll show you later how to get it. Times the sigma. Sigma is your population variance divided by sub n. You know what's n? Where's n? Chapter 2. N is what? Total? Total what? Sample rate. Hello? Is it total sample? Chapter 2? The formula. Okay, now, if you want to split this out, or you can write as x minus, you see the minus, this one, or plus 1, you put it the right hand side. Plus right hand side minus left hand side. I split this into left and right, lower, upper, boundary. So this will give you the confidence interval for the population mean. Mu is the population mean. Yeah, right down here, mu. See, plus is bigger, always right hand side. Minus is smaller. Okay, so the next question is, what is the alpha? How to find alpha? Okay, I give you an example here. Let's say I have 90%. Sample round. 90%. Let's say this is 0.9. 0.9 means 90%. So what is my alpha? I change back to what? 0.9. 90% I change back to 0.9, right? So I compare 0.9 with 1 minus alpha. So that means 1 minus alpha should equal to 0. So what's my alpha? 1 minus 0.9 is 0.1 already. Okay, let's say we take 95% here, 0.95. Can you find the alpha for me? Everyone, can you find the alpha for me? Let's say, can I write here? Can I say 95% or 0.95. We know this is what? 1 minus alpha should be 0.95, right? So what's alpha? 0.05. Anyone have any questions? Those at home now, are you all still okay? 100 over today. I'm going to the rest. Okay, so this is how we get alpha. Why alpha is important? Because we go back to table 2 later to find the z-score. Okay? See, your alpha over 2 is here. From the alpha, you divide by 2, you know the z-score, table 2. Okay, next, the maximum error for estimation is given by this part. You see this part? This is the formula to calculate error. Those of them who do research on, they will need this to make sure their error is very small. If your error is very small, means your research result is good. If your error is very big, your research result not very good. Okay? So this one you leave that to researcher. Okay, let's do some calculation now. To determine the mean waiting time for his customer, a bank manager took a random sample of 50 customers. So what's 50? Sample. N is your 50. Okay? We need all this up. So N is 50. And found that the mean waiting time was 7.2. What's the mean waiting time? X bar, right? Don't confuse X bar and the mu one. Mu is the one you want to calculate. CI. X bar is the one given for this. And then assuming the population standard deviation is the sigma, right? Sigma is 5, you see? Sigma is 5, right? Standard deviation no square 1, right? Remember, chapter 2? And find the 90%. 90% means what? What's the alpha? Just like I mentioned, right? 1 minus alpha equal to 0.9. 90% you change to 0.9. So what is your alpha? 0.1. 1 minus 1. Anyone don't get? Those at home, anyone don't get? Okay, very clear. So you see, you get all this idea. We are going to plug into the formula to find the CI. Now, before we plug into the formula, alpha over 2. Do you see this alpha over 2? So you need to take the alpha. What's our alpha? 0.1. So alpha over 2 means 0.1 divided by 2 means 0.051. So that means that alpha over 2 now is Z. 0.05, correct enough. The whole thing divided by 2 only now. Okay? Now, can you tell me how to get this? Can everyone go back to table 2? I share my screen first. Table 2. I show one time only. After this, I don't want to keep on coming back to the table 2. Those of you who have gotten ready, let me share my screen now. Table 2. Can you see the screen? Can you remember this? So tell me where is 1.6449? Remember all these are Z score, right? I show you, see, I label already. And alpha refer to the one you calculate just now. So remember your alpha over 2, right? Alpha is 0.1, right? Divided by 2 is 0.05. So you check this as whole 0.05. Don't look at 0.1 now, because you need to divide by 2. So you look at the 0.05. 1.6449. Don't look at 0.1 now. It's 0.1 here. Not this one now. You have to divide by 2. Any questions? Okay, let's do some testing now. Okay, because I don't want to come back again for this table. Let's say your alpha is 0.3 based on 97% now. Based on 70%. 70% now. So 1 minus 0.7 is 0.3. So alpha over 2 means what? 0.3 divided by 2, 0.15. So you have to look at 0.15. Don't look at 0.3. 0.15 is here 1.0364. Cannot. Don't forget to divide by 2. Then let's say I have another 80%. 80% means that alpha is what? 0.2. 1 minus 0.8 now. So when you divide by 2, means you have 0.1, right? 0.1 means you have to look at this one now. 1.2816. Okay. Now I tell you why we have to divide by 2. Do you know why we have to divide by 2 or not the alpha? What's the reason? because we talk about two sides. Listen carefully. Why we divide by 2? Because we talk about divide by 2, up, lower, and upper. So divide by 2. This one very important. When we ask students why we divide by 2, many of them don't know how to answer. Sometimes alpha no need to divide by 2. Later when we go to hypothesis chapter, remember, sometimes you see that one tail test alpha no need to divide by 2. We talk about two tail tests, left and right, lower upper boundary. Remember, estimation we have to divide by 2. Simple as that. Okay? Clear? So I hope everyone know how to find the Z score coming back to this table. So let's go back to our notes here. Okay, now 1.6449, no issue already, right? Everybody know how to find it. So can we calculate the 90% confidence interval? So what's the formula? This is the left-hand side, right? This is the right-hand side. Both formulas the same. 1 minus 1 plus 1. Okay, can someone calculate x bar is what? 7.2 minus this one 1.6449 times the sigma, which is 5 over 50. For the right hand side, you do the same. 1 plus and 1 minus, okay? So can someone tell me what's the answer? Anyone have the answer? Because of you have the answer, can type in the chat box so that I can just share it copy and write on the dummy there. 7.2 6.036 is it? Yeah, 6.036, right? The lower boundary. 7. Can you use for decimal point? This one? Still calculating, everyone. Yeah. 8.363. Everybody okay? Any questions from anyone at home? From the DK here, everybody still calculating? If you need help, you just type in the box there. Yeah, everyone? Clear? So can we move to the next one? Now you all know the symbol already. You see there are so many symbols here. Make sure you don't mix up the name. Okay, I think everyone no issue. We move on now. Okay, in the random sample of 70, so what is this? They are not given any answer, right? So can you fill up yourself? N is what? Sigma is what? X bar is what? Again, found that the mean weekly time spending to do homework is 14.3. So what's the mean here? X bar, right? 14.3. If you assume that the homework is normally, I think normal, related to table 2, right? Normally distributed with a standard deviation of 4. This is your standard deviation of 4. Find the 99%. Can you tell me what is your alpha? 99% means what? 0.99, right? So you have to find the 1 minus alpha equal to 0.99. So alpha is what? 1 minus 0.99. How much? 0.01. Don't make mistake. So what is your set alpha over 2? Everyone, for estimation, your Z score, I told you, right, got two sides. Your alpha must divide by 2. So Z 0.01 divided by 2 means Z 0.005 by it. How many 0? 2 0. Okay, your table 2. Can someone tell me what's the value? Again, 2.5758. And when you get 2.5758 from table 2, look at 0.005 divided by 2 only. Divided by 2 only. Anyone to get at home? 2.5758. Okay, so where are we now? Your n is what, 70, right? So can you find the 99%? Remember, we are 99% sure or confidence that the beta, the Z score is between. Can you calculate now? Use the same formula. This one. Minus and plus. Just give me the answer. Someone type in the chat box. I ask the answer so someone can type in the chat box if you have confidence in your answer. Sorry, 13.07 Go Boon Chen. 13.07. Can we have more decimal point? Aaron, if you can, write 4 decimal point. 0.1, 13.0. 685. More decimal point means more accurate, 685. The right boundary, 15.1. Anyone? 5315. Okay. See, right hand side always more than left hand side because plus 1, this one minus. So you okay now? That means if I draw the normal curve, let's say everyone, remember, let's say this is your 13 point. Let's say this is your mean 0. 13 point something is positive 1, 15 point something also positive, right? Both also positive. So let's say this is 13 point something. This one is 15 point something. So this is your boundary. We call it estimation that we are 99% confidence the Z score is 4 inside here. 99% sure. And the balance is what? 1%. 1% means what? Everyone? Not sure. Okay, 99% means confidence one. So the balance is 1%, which is not sure, not confidence one. In other words, when you learn higher level statistics, 1% means what? This 1% is called error. Not sure means you don't have confidence, it's called error. So I give you this word error. Now remember just now there's a formula here called error. Now in statistics, when you do research, next time do your final project or whatever, the higher the error, I told you just now, means what? No good. Your data is no good. If you want your data good, you have what? As minimum as possible. The error, the lower the better. Means what? More accurate. So that's why if you have 99% means very high confidence, 1% error. Let's say you have 95%. If you have 95% means you have 5% error, 5% not sure now. So which one is better? Of course 99% is better because higher than 95%. The error also lower than 5%. Fair enough. But in statistics, I would like to highlight here, our common alpha is 0.05. You see, 95% means the alpha is what? What's alpha? 0.05, right? If you learn statistics in higher level, most of the questions, in fact, our questions later on, you can see the alpha many times. This is the common alpha we use. 95%. Because if you use 99%, people argue too accurate, too excellent. How can you be 99% so sure one? This is the argument by last time. So now they say, okay, now statistician worldwide, they agree to take 95%. Layman term say 95% is okay, 5% error. So that's why a lot of question data you see the classification, whatever. In fact, in most textbooks, in the library, the website, you can see a lot of writers, they use alpha 0.05. Okay? Enough. So, the next thing is extension from this formula. Just now we use what? Sigma. This is the population variance, right? Okay, let's say we don't know what is the population variance. We use what? S. For unknown sample, we call this unknown. So let's say we don't care. Okay, we use this variance represented by the, we call it sample variance, small s. Remember chapter 2? The formula is still the same. So if the question mentioned the sample variance or unknown, then you use this as well. So a lot of people ask, is there any different? I say no different. Both also, it's just a symbol change. Any big group become small group. All right. This one always given if the n is more than 30. If it's an unknown, we use the S. So don't worry. A lot of people they don't care one in exam. Supposed to write S, they still write sigma. So we still go because they say, oh, by the time I want to make sure is it S or sigma already 5 minutes over. So don't care, I just write the formula. Because it's not going to write the answer. The question only give you one very known that is a standard deviation. So people don't care whether it's a sample or population. Alright? The sample. And then the maximum error again is the same one, like this one. Just now we use what? Sigma 1. Now we use S. Okay. Right. Let's give you one example to differentiate why we use S here. You see the word sample? Then we know this is what? It's not population, right? It's a. See your X bar is still there. S is 0.42. Understood with you? So your N is what? 200. You know what's ball bearing, right? Is it in the tire one? Car tire, bicycle tire, there's a ball bearing one. I think so. So the 1 week mean show 8.24. So this is your sample mean, X bar. There was alpha. 95% as we know, 0.95. So the 1 minus alpha is 0.95. So alpha is, you get 0.05. So divided by 2. Can someone check, double check, table 2? Is it 1.96? Zero point zero two five, right? Divided by 2. So from table 2, 1.96. Okay, so can you find the 95% confidence interval for the mean? In someone type in the checkbox. So you see, as I said just now, some people they don't care what they put sigma also. Still 0.42, right? Because it's only one variance here. Alright, should be simple. To finish, you can try this example. Any answer from this example? Sorry, 8 point. Left hand side. 8 point. 1818. Right hand side. Or 81818. Good number. 8.298, Brian. The 8.298. Okay, this one. See, a lot of question, 95%, right? Right? But actually, we can change one now. Can change to 80%, 70%, 99%, 98%. Anything is possible. But as I said, the standard international one, they say 99% too high. By the way, there are no such thing as 100% one confidence. In this world, there's nothing 100% for sure. 99% is very high already. So we take the lower average, which is 95%. Okay, this is population mean. We have two types, one using sample and one using population. The only difference is one use S and one use sigma. Any answer? Anyone have a calculator type in the chat box? Oops, where is my screen now? I left already, right? Do I still in the classroom? I'm out already, right? Do I still in the classroom? Yes, sir. How come I cannot see here already? I might. I try to go back again. Okay. Got to someone. Yeah, which one? Mine. Because I cannot see the other screen already. Can I see I right here? Can oh, that means I cannot see from my screen already, the classroom. So what's the answer? And based on this, I only have one screen now. Based on this, what's the left lower boundary? Sorry? 236 point 0244. Right inside. 243.9756. Okay, everyone. I can see from the screen there. 95. 95 what? Okay, I hope everyone get this also. Okay, so can we move to the next one? Confidence interval. Now, just now we talked about population mean, right? Take note, this is number one, population mean. So we use the mu. Okay, mu. Now we talk about second type of confidence interval. We call this confidence interval for population proportion, not population mean, now proportion. Proportion means we use P. P. Now, in chapter 4, to remember the binomial distribution, what's the P? Success probability. Q is what? Q is the failure, remember? So proportion is your P. Do you remember? X is your number of success. P is the probability success. And this is your binomial, right? Okay. So sample proportion. You see this P with the bar here? You see that? Okay, it's a bar head, right? Let me see this one. Yes, it's a bar head. They don't use the P head. No, P head. Okay. X over N. So X is the number of the success out of the N total sample. Okay, N is your total sample. So you can divide, then get the proportion. Okay, now this is the two formula which you're going to learn in the higher level of statistics. Anyway, we write down here. If you want to approximate or large N, let's say your N here very big, a few hundred, a few thousand of data, you can approximate this binomial using the formula with your mean now NP and your variance NPQ. 1 minus P is Q. Yeah. Now don't worry about this. This one is not in your study yet. And for proportion, we can also estimate using, if the N is very big, we can also estimate the sample proportion as normal with your mean as P, and then your variance is P times Q over N. This is what? P, 1 minus P is Q now. So P times Q, this one, over, and this is your variance. Okay? Estimate this is a variance up. So same thing for the population rate. You want to estimate the alpha, use back the same formula, 1 minus alpha percent confidence interval for the population proportion P. Again, the N is let's say more than 30. It's given by this formula. Now, just now compared to the mu, we almost had the same formula. P hat left hand side be minus, right hand side be plus. Can you see it now? Like the mu, right? Right hand side plus, left hand side minus. So the right hand side always bigger than left hand side, lower, upper. But the formula here different already. The Z alpha over 2 still the same. How to find alpha? Still the same. But the difference here is the style our population mean is what? X bar plus minus Z alpha times sigma, right? divided by the n. That is called mu. But this is proportion. So your proportion is for this one. What's proportion for this? P times Q over N. This is your standard deviation. So you see this is a square root because S square don't have square root, so you take square root. Yeah. What's your normal formula? Recall chapter 4. Mu n sigma square. Remember there's a 6 square here. This is your mean, right? So your mean is P lah. That's why you see P here already, no? Then your sigma square is what? See, I take this sigma square, go to this one. P times, I change this one minus P to Q. So P times Q over N. This is what I write here. So I don't want the sigma. I have to take the square root. See? This is your sigma idea. Okay? Over. So, and this whole thing is your standard deviation already. Okay? For large number, approximately like that. Now you learn more about this in your higher level. What we want is you just have to memorize. This is the formula for proportion. This is the formula for mean. Okay? Two formula only now. So can I go on? Okay, now your P is between lower and upper, right? Okay, again, this is your error. Remember for mean, this is the error, right? Formula. For proportion, this is the error formula. Okay. This one. So can we do some example? When manufacturer wants to assess the proportion, so you ask me, how do I know it's mean or proportion? The question we mentioned very clear. Proportion of defective items in a large batch of produced by the machine. We test a random sample of 300. So what's the N here? 300. And finds that 45 are defective. What's the meaning of 300? 45 are defective. Find what? They give you 300 and 45 are defective. What are you looking for now? This one. You need your sample proportion. What is the p hat, right? Because p hat. You need to find this. You don't have this, then how you find your CI? Sometimes question given. Sometimes you have to find yourself. So let's find the p hat. 45 or 300. Proper. Calculator. 0.15. So can you tell me what is Q hat? 0.85. So that you can put into this formula, P times Q, 1 minus P is Q now. Okay, so calculate 98%. Is it 98%? No more 95%. 98%, what's alpha? 0.98. Compared to the percent. So 1 minus alpha, 0.98. So what's alpha? 0.02 there. So that means our set alpha over 2, which means that 0.02 divided by 2, which is z 0.01 from the normal table 2. What do you get now? 2.3263. Everyone get this? So your 98% proportion population of CI is given by this formula, right, everyone? Left hand side, right hand side, plus and minus 1. Let's see. Anyone need help? You let me know. Otherwise, you give me the answer left and right.
Sir,
Mm.
YP is equal to 45 over 300.
Why 45 and x given here?
I thought it's
45.
P equals X over N.
Yeah.
X
N
is
is what?
45.
X is 300. N is what? 45. X is 45. X means the number of, you see here? Number of success, number of effective, number of spoil, number of whatever. This is X over the N. That is your sample proportion.
Oh, okay.
X is the how many out of the choice N, how many. So out of 300, how many defective? 45. Everyone. So this why you have to calculate the p hat. Any more questions? So can someone give me the left and right? 0.1020 answer 0.19. Any answer different? Okay. Now, you see here, some questions as mentioned very clear, you have to find the p hat. So you all know already, the formula is x over n. N is the total sample. X is out of the n, how many success, how many defective, and so on. Now you calculate yourself. But some question, you look at this example, if you are lucky, the p hat is given, you see, in an opinion poll conducted by sample 1000, 30%, what's the mean 30%? That's your p hat already, look. See, you're lucky, look. You're given the p hat 0.3. No need to calculate already, look. So your p hat is 0.3, that means your q will be 0.7. Alright. So they support the political party. Find 95%. Again, 95% means your alpha is what? 0.95. 0.05. So Z alpha over 2 is Z 0.025. What's your Z score? 1.96. Okay, put into the formula and then you calculate 95% CI for population proportion. Has any question from the students at home? Can you help me to see? Any of them post questions? No, right? Okay. I don't know where's the screen already. Okay, any answer from anyone? 0.2718 right inside 68 16 right inside 0.3284. Okay. So that means you have 95% confidence Z score between these two ranges. 5% will be outside. 5% error means they're outside from this range. Okay, now, just before we go for a break, that means the part 1 finished already. Estimation part 1 finished already, so you all can do your tutorial 5. Yeah, part 1 finished. Done. So can we do part 2? This is the one challenging hypothesis testing. Now, remember for estimation just now, I repeat, for estimation, we want to estimate upper and lower, right? So we divide by what? The alpha have to divide by 2. 1 positive, 1 negative. Can you see or not? 1 positive, negative. That's why you see a formula here. 1 positive, 1 negative, huh? And alpha must divide by 2, huh? Because we talk about both sides, lower and upper. However, when it comes to hypothesis testing, are you ready? Okay, this is the one challenging. I need you to think, in hypothesis testing, let me explain to you what's the word hypothesis. Hypothesis is actually a theory or belief about a population parameter. Using some sample information, we may want to know whether a given claim or a statement about a population parameter is true or not. So when we talk about hypothesis testing, we want to test what? Test theory or belief. You know what's called belief? Belief means past what? We call it past experience. What we call this in Mandarin, belief? Kepercayaan, is it? Past experience. Is it true or false? Test the theory or belief past experience are true or false. So I want you all to take note these words. Either true or false. Example. Everyone don't get offended. If I say girls are smarter than guys. No, not necessarily. I just mentioned only. Girls are smarter than guys. Theory only, okay? So far, nobody knows. This is the past experience. Belief, they say girls are smarter than guys. Yes, some research find that girls are not so, a lot of things are good things about girls, a lot of good things about guys, but they compare also. So let's say this is the statement. Claim. Claim means what? People say girls are smarter than guys. So do you believe or not? How many say true? How many say false? This is called hypothesis testing. A lot of example later on, we call it claim or statement. Then I can give you an example. Let's say a manager working in a company, right? They say a lot of the workers not doing well in their project. This is another statement by the manager. Let's say example. So is the workers agree with the manager or not agree with the manager? True or false? Okay, so when you go through the exercise later on, example, you can see there are a lot of claim or statement. So our job is to test whether true or false. If true, agree. False, reject. Okay? See, we either accept or reject. Can you highlight this further? So in answering these questions, everyone, later when I give you the full answer for example, accept or reject. Then you ask me, accept what? Reject what? Okay. The theory or the belief. Of course, we are not going to, let's say girls are smarter than guys. Then you cannot, you need to say, I accept this statement, say girls are smarter than guys. No. You are going to use this called H0 and H1. Okay. Tentative, you will write down this one first. I explain to you. H, see the small circle there. This is called null hypothesis. Null hypothesis. This is called alternate hypothesis. Okay, you see the spelling later on. Now, this is your statistical hypothesis, a statement or belief, blah blah blah. Like what I said just now, girls are smarter than boys, female are better than men, and so on. Okay, experimental sample is to take the analysis and then print out the report to show that whether true or wrong. Okay, now this is the one now I mentioned, H null hypothesis. So a claim or statement about population that is assumed to be true until it is declared false. So when we do testing, we have two types of hypotheses. Remember now, H null. So what is H null? H null always support the statement. They say girls are smarter than guys. This is your H null. So we have to give another option. We call it alternate. H1. H1 will be the people who say, I don't agree. Understand? H0 people say girls are smarter than guys. This is the statement. They say true one. Then H1 is who? These are the people who reject now, who always what? We call it contradict. You know what's called contradict? Opposite one. Opposite opinion, which they don't agree. They will reject. Girls are smarter than guys. Anyone don't understand? This is the one. Alternate hypothesis. A claim or statement that will be true unless it is H0 is false. You see, they will say the H1 is correct one. Alright? And then they say that H0 is false. The other way around. See, H0 correct, then H1 will be so you have to prove which one is winning. Siapa menang? H0 menang or H1 menang? One person can win only. The girls is smarter than guys. Either H0 correct or H1 wrong. If H1 correct, it means girls are not smarter than boys. So those who say H1 salah already. Okay, only can choose one, only one, right? So there is no two correct one. So your job is to test how to get one winner. So we have to do like this. We accept a true hypothesis if it's a correct decision. We reject a false hypothesis based on the correct decision. Okay? Now, this is what I call type 1 and type 2 error. Those of you who learn higher level next time, just like I mentioned, 95%, remember 95%, let's say this is the CI, right? So what's the error? 5%. Okay, 5% is the error. So this is what? Type 1 and type 2. So in future, if you learn this, you have to pay attention on that. Okay, so I'm not going to spend so much on this. Okay, I'm going to go straight. How do we know which one you reject, which one you accept? Okay, based on the H0. Our decision is always based on what? H0. The rejection of H0 means accept H1. This one wrong, this one correct. In other words, the acceptance of H0 means we have to reject H1. The same meaning. Okay. So I won't spend so much time on this. I want to go straight to the steps. Right now, let me repeat again the alpha. As you all know already, the alpha is the significance level. Okay. And as I mentioned, for type 1 error, okay, what you're focused on is type 1 error. Let me explain a bit. Usually the test type 1 is actually using 5%, or which is the alpha 0.05 or 1%, 0.01. This is the one that we use, as I mentioned just now, 95%, and this one is 99%. Okay, so like I say, most questions still use this stuff. Okay, now, so this is the one that I explained to you just now. So you can read yourself. You say that 5% error of rejecting when it is true. Okay, that means you get the error because actually you accept it, whereas you still reject it, so you make error. Yeah, now this is the meaning here. You can read yourself. Now, what I want to start is when you want to do hypothesis testing, you have to have this test statistics. Test statistics is a number calculated, so you see the formula from the sample that determine whether you will accept or reject a H no. Okay. The next thing is, okay, can you highlight this number one? You need to calculate this up. I will show you the steps later on. Number two, you need the critical region. Now, what is called critical region or rejection region? This is the area which will determine the levels of significance. Now, listen carefully. We are entering the steps now. If the test statistics, the one that you calculate, number one here, falls in the accepted region means the H0 is correct. Now remember, our job is to focus on H0 only, because when H0 is correct, H1 will be Salah, automatic one, right? You only concentrate on H0. If your H0 rejected, betul means accept, can you follow? Salah means reject, or we call it do not accept. I write down here, reject means do not accept. Same meaning, right? So means Salah. Salah means automatically your H1 will be correct already now. Only one person can win. So, but in testing the hypothesis, we only can test the H0, not the H1. So far, okay, right? Very well. So, if the test statistics fall in the rejection H0, meaning that, can I draw this normal curve again? Everyone? Let's say this is your standard normal. This is a mean, right? Let's say your Z is here. Let's say, remember Z can be positive, can be negative. Let's say your Z is here with the value alpha. Remember the alpha? So you've seen the log table 2, right? The Z value. Let's say this test statistics fall. Do you remember table 1 normal? Our probability is always outside 1. Let's say this is the reject. Anything outside here or inside here will be reject. H0. Everybody pay attention here. Any test statistics value for inside the acceptance region, accept. Okay, show later where is the acceptance region now. So let me show to you rejection region first. Now, if the test statistics fall inside here, the shaded one, this is reject H0. Reject H0. So where's the acceptance? This one, the big one. This is do not. This is reject. This is do not reject, which means accept. Accept here means do not reject. Can I write down here? Accept means do not reject. Everyone follow. So tonight you have a lot of things to think before you sleep, right? Everyone go through this notes again. Do not reject what? H0. Remember, our focus is only H0. So the shaded one, if the test statistics, let's say the calculator, the value is more than this, reject H0. Reject H0 means what? H1 betul already, right? Because we reject means Salah H0, H1 betul already. So that means the girls are not smarter than boys. Because H0 saying girls are smarter than boys. I use this example. Okay. Now, let's say if your test statistics calculate is less than this set alpha value. Remember this alpha value. So if for less than this left hand side smaller, then you do not reject H0. not reject means what? H no betul mah. You don't reject means H no. So true lor. So that means H1. Salah already lor, automatically. That means the girls are smarter than both because H no win already mah. True. I had to use creativity way to explain to people. So later when you do the test or sorry, to your question, whatever, right? I'm not saying the question always say girls are smarter than boys. It can be anything. So you read through the question carefully. You write down your H no. You write down your H1. Then you determine whether reject or do not reject H no. Okay. Next, number 3. Do you remember this alpha? This is the critical value, which is the example like Z alpha over 2. This is the value that separates rejection from acceptance. See? You see this line here? This is the separate rejection area. More than, or inside here, reject already. Less than means the left hand side, do not reject. This is the Z score that separate rejection from acceptance. Very funny, right? So, just like I mentioned, your Z, sometimes alpha no need to divide by 2, sometimes you have to divide by 2. Why like that? Just now when we talk about estimation, alpha have to divide by 2, right? Why? Because you talk about lower and upper boundary, so you divide by 2 now. But why in this hypothesis testing, why we have 2 here, option? Sometimes no need divide by 2, sometimes have to divide by 2. Can anyone tell me? Okay, I give you the tips first. Alpha means 1 tail test. A 2-tail test, you have to divide by 2. The next sentences explain that. The critical region may be represented by a portion of the area under the normal curve in 2 ways. 2 tails under the curve that I draw for you. Remember chapter 4? We have a left tail and right tail, correct? So your left tail and right tail, you have to consider both sides. If your test is based on 2 sides, your Z alpha have to divide by 2. See, 1 positive, 1 negative. Like your estimation, right? Plus and minus 2 tail. If it's 1 tail test, then we have 2 scenarios. Either you test a positive, only one side positive right tail. So my alpha is no need to divide by 2. Or, you see, I use the word or. If I test based on the left hand side. So we test the left hand side. I write negative side here. See, alpha also no need to divide by 2. So this is right test, right tail test. This is left tail test. Both of these are 1 tail. So alpha no need to divide by 2. Can you remember? Look into your mind here. If the question tests for 2 tail, you have to look at left and right. Alpha have to divide by 2. So the next question you ask me already, how do we know it's 2 tail or 1 tail? That is the challenge. When people answer the question, they read the question so long, they already don't know, is it 1 tail or 2 tail? Why? Because if you answer wrongly, supposed to be 2 tail, you answer 1 tail, everything gone. Supposed to be 1 tail, but you answer 2 tail, also gone. because alpha and alpha divided by 2 totally different z score, right? Correct. You use the paper 2, you know, right? So let's start. Any questions before I continue? Can we stop for 5 minutes break? 5 minutes break, everyone. Those at home, 5 minutes break. Go to wash your face, jalan. Okay, quickly come back.
The toilet still closed, right? Run there, run here. 5 minutes already. Okay, hurry up.